I think the thing that we need the most practice on this week is templates. And I'm going to admit that a couple of minutes ago, before I started this recording, I tried to start this video, and then I gave ChatGPT one of the usual prompts, and it just went way off the rails. And even after a bit of arguing with it, it still was way off the rails. It was suggesting that it was giving me practice questions that were incredibly advanced, like way above the level of this course, more suited for like a fourth year course. The issue is templates are a very complicated subject. I mean, they're used for all sorts of important infrastructure in the language, and maybe that means that without a very careful prompt, we get things that are basically useless as far as our practice is concerned. So for that reason, this time, we'll just try it again. This time I'm going to give it a pretty tightly constrained prompt. I want some practice writing basic templated code in C++ 20. Can you generate some simple, maybe simple's going a bit too far, some template programming exercises with the following constraints? The exercises should all be functions in one large program. A main function is already written containing tests for each function. The templated functions are missing for me to implement myself, but in place of each function is a header comment containing a formal specification of the function. Don't show me the solution, and then critically, the only types used in the program as arguments to templated functions should be, let's just make a list: int, char, double, float, string, I'll say std string. Let's do vector and list. Actually, we'll allow list and set. In my previous attempt that I had to give up on, basically it was trying to make me generate templated code that worked with all sorts of bizarre standard library features that are commonly used for templated things but not commonly used in CSC 116. So we'll just list all the types we're willing to work with today. This will also allow us to avoid it suggesting that we write a linked list or something on our own, because we don't want to do that because that's next week's topic. All right, well, let's just hope for the best. Keep our fingers crossed here. Certainly. Let's see how much of that request it actually understood. I wouldn't be surprised if some of this actually ends up being stuff we've already done. But okay, so it looks like it's generated, a lot of these are pretty straightforward, frankly, but whatever. If I'm being picky, I guess I have to abide by that. It didn't actually write the test cases, which is annoying. What I'm going to do is grab the template, grab the starter code, and then head back over here, paste it in, and now I'm just going to ask it to write me a main. Can you write a complete main function that includes comprehensive tests of each template, of each function? And we'll just see if it can do that for me. So it's thinking. I've been giving it a pretty hard time today. All right, yeah, here we go. So here's some tests, and then we'll go and take a look. What's interesting about this is I don't know how able it is to understand when types can be deduced or not, but observe that in the main function it generated, we don't see any angle brackets. It's assuming that the type of everything can be deduced on the fly. So we'll copy this, we'll head over here. We'll probably end up doing a lot of the same exercises we did in lecture exercises, but whatever. If we get a couple of new ones in, that's probably nice. I'm also expecting to need to do a little bit of clarification. Yeah, I'm going to have to request a few clarifications. These two-line comments are not formal specifications. It's weird because if I ask ChatGPT specifically, give me a formal specification for function X, we've already seen it generates a pretty good detailed specification. If I say, give me some starter code with formal specifications, I use the same words, it doesn't do it. It gives me these two-line things. Okay, so it says max element should take an array and return the maximum element. Already I'm going to need a clarification here because what do I do if it says array, but it means vector. What do I do if the vector is empty? So I'll just go ask. We'll scroll all the way down. For max element, what should I, actually, I'll just say give me a formal specification. Please give me a formal specification for max element in the form of a header comment that also includes a specific policy for dealing with the case in which the input vector is empty. That's way more words than I should have needed to use. Sure, okay, so here we go. Here's a formal specification. We'll copy the, we'll click the copy button. We'll see if we can grab it before it scrolls back down, and then we'll paste it in. All right, so what I wanted to say is basically either, throw an exception or something when the vector is empty, because you can't find the maximum element of a vector with 0 things. It takes a vector of a comparable type. So this is a very technical term. It's not obvious. I mean, the word comparable is just there, but what I interpret this to mean is a comparable type is something that has a less than operator that I can use. Otherwise, how do I know what the maximum is? And actually down here, it looks like it agrees. It says t, which is the element type of the vector. So if you look at the signature, it takes type name t, and then t is being used to parameterize the vector. T, the element type of elements in the vector, which must be comparable using the less than operator. So when I see the word comparable, I interpret that to mean that there exists a less than operator. Okay, and so I'm going to return the maximum element of the vector. If the vector is empty, I'm going to return, oh, that's too bad. I'm going to return a default constructed value. I'd rather that it be that it throw an exception, but this is also a valid policy. So what it's saying is t is the element type of the vector. So I want a default constructed instance of t. This function throws nothing. This is a much more formal specification than we're used to. So I'm glad it was able to turn that around. All right, so max element. I guess the way I'll handle this is I'll begin by handling the case where the vector is empty. If vec.size is equal to 0, well, in that case, create a default constructed version of so I'll say default element. So I'm just creating an object of type t with a default constructor, and then I'm going to return the default element. Now, this therefore requires that whatever type I'm working with as t, so you can't call this function unless the vector is of a type whose default constructor is public, because I'm trying to call the default constructor here. That's one reason why I don't like this specification. I'm going to implement it, but I'm going to complain about it. I think the best thing to do if the vector is empty is to throw an exception, because if I do it this way, then I'm not allowed to call max element on any vector of an element type without a default public constructor. Even if I'm sure I never am going to call it on an empty vector, it still requires the element type to have a default constructor that's public before I'm allowed to use the function. Now, otherwise, what do I do? In this case, I guess I am allowed to maintain, it seems like I am allowed to assume, I'm going to ask whether I'm allowed to copy elements. For max element, can I assume that the type t can be copied? And I'll explain what I mean by that depending on the answer. Yes, I can assume that that's interesting. I can assume that the type t can be copied when implementing the max element function. It turns out that it's claiming that vector requires its elements to be copyable, which I don't actually fully agree with. There's a little bit of nuance to this statement that ChatGPT, this is a bit too definitive of a statement, but okay. So what I was getting at with that question, with that clarification, and you can see why my previous attempt at a video like this went off the rails. You need a lot of these clarifications for this sort of exercise to make sense at this level. What I'm getting at is, am I allowed to store a copy, to make a copy of the elements of this vector? We know that some types can't be copied. If you make a vector of those types, what are we going to do? What ChatGPT said, that everything in a vector is always copyable, is basically false because of some semantic nuance, but I have now gotten its permission to make a copy of an element. So what I'm going to do is I'm going to create a copy of an element to store the maximum element, and I'm going to start that by just making a copy of element 0. This is the usual way I compute the maximum element of a vector. And then I'm going to loop over every other element, or actually every element of the vector. I'll be a bit sloppy there. Auto element in the vector. And because I'm allowed to make copies, I can even write a for each loop that makes copies, although in this case I will do auto ampersand. So I'll just loop over the actual elements. I'll say if element is, oh, whoops. I'm only allowed to assume that there is a less than operator. I'm not actually allowed to assume that there's a greater than operator. So I'm going to do this. If the current maximum is less than the element I'm looking at, well, in that case, I'm going to set the maximum to equal the element that I'm looking at. And then when I'm done, I return the maximum. Now, the next question is, can I run this? Oh, there's another copy of the max element signature from when I copied and pasted. I think if I want to run this code, I'm going to need to add return statements to everything, everything else in the code. No, the way it's written, if I omit return statements, I'm going to get a lot of warnings, but I don't think the program will crash, except maybe for this one. But let's just see what happens. Okay, so it's giving me all these warnings. Let's try running it. It doesn't crash, which is nice. So the test case for max element says find the maximum element in this array of ints, and it finds, let's see, it says 5. The maximum double is 5.5. That looks like it works. I could even ask for the maximum string, because strings have a less than operator. I'm going to do that. It should return the alphabetically largest. So in alphabetical order, which string comes at the end, which is the maximum. So I'm going to put the word cherry in the middle of the vector, because that's going to be the maximum, just to make sure the maximum is not at the end in too many of the test cases. So I'm going to say max string, and then I'll print out... I'm just going to do auto max string, and I'm going to initialize it. I'm not going to use the C-style initializer. Max element of stir. Oh, I see. So I can't compute the maximum of this list of strings because the max element function only works with vectors. So I'm just going to leave it here. That's too bad. Now I could, we've actually seen an example in a lecture exercise where I could extend max element to work for lists or vectors with a little bit of ingenuity, but it's given me an exercise. I'm just going to do it. I'm not going to overcomplicate things. So here's my solution. I've observed that I have a couple of issues with the design of this solution. So for example, that I have to default initialize something, which otherwise wouldn't be required. I could just throw an exception here. Also, something for you to contemplate is, what would you do if you weren't allowed to copy elements? So what if you're only allowed to look at elements and you're not allowed to make copies? I make copies of elements in two places. On line 37, I copy vec.at0 into max, and on line 40, I copy something else into max. Suppose you weren't allowed to do either of these copies. There's no copy constructor, there's no copy assignment. What would you write? Something interesting to think about. And it's interesting to think about that because when you write code that's templated, you actually sort of change your design philosophy a bit. You want to write code that makes as few assumptions as possible. When you write code that isn't templated, you often make assumptions, and you just have to make sure to justify them. When you write templated code, you may still need assumptions, but you want to try and make as few of them as possible. Even if you can justify them, you want to still avoid making assumptions. So I'm going to call max element complete. I haven't done the same rigorous testing I would have done earlier in this course, but that's because, just like with a lot of our recent exercises, this is mostly a syntax exercise. We're making sure we can write templates, not necessarily that we can write the max of a vector operation, because we've already done that. What's next? Let's see, swap elements. Now, I really don't know what there is templated about this. Oh, I guess, yeah, okay, I see. So I want to swap two elements of a vector, and recall that whenever you want to swap two things, so suppose it was a vector of int, I would make a temporary item. It says swap the element at this index with that index. So I make a temporary variable, I set it to array.at index 1, and then I set array.at index 1 to be equal to array.at index 2. And then I set array.at index 2 to be equal to my temporary item. Okay. Now, what makes this a templated thing is that I need to use type T because this may not be a vector of int. Now, I could use type T. I could write that. This also requires that elements be copyable. Although in this case, that assumption is natural because if I'm swapping elements, I'm going to need to copy things around. So of course, if they're not copyable, how am I ever going to swap anything? I could use type T here, but I won't. I'll just use auto, because if I wrote this for anything else, even if it weren't templated, I would probably just use auto there. So we'll use auto. We'll see if that works. Okay, so let's take a look at the test case. The test case is in the vector int_vec. I want to copy, it makes a new vector. So it makes a copy of this vector so that when the manipulation happens, it doesn't percolate through to the rest of the code. I want to copy swap index 1 and index 3. That would be the 3 and the 5. So I expect it to be 1, 5, 2, 3, 4, if I'm reading this correctly. So we'll run it. And it says 1, 5, 2, 3, 4. Okay, I think, again, because we're focusing on the templated aspect, not the underlying algorithm, I think that swap elements now works. Maybe more testing is needed, I don't know, but I think I'm going to call swap elements as working. Now, count occurrences. This is a solid exercise. So here, I'm given a container of any type, vector, list, or set. I guess maybe other types too. And a particular element value that I want to count the number of occurrences of. So it's sort of, I don't know, it's not a very interesting exercise with sets because we know that a set can't contain duplicates, but it could contain 0 occurrences or 1 occurrence. So I guess what I'll do is I'll initialize a variable for my count, start that at 0. I'm eventually going to return the count. The return type is int, so there's no templating involved in that. And then I just iterate over the vector. Now, here I could write for each element t in my container. I shouldn't say vector, it's an arbitrary container. Just do this. And I could even use a reference type here. Then I could write if element is equal to the value you had me search for, that's this thing, then I increment my count. And I'll run that. Well, we'll see if it works. Maybe it doesn't. It looks like, oh, it's giving me, yeah, that's a good point. Okay, so here, it's a constant container that I take as my argument. And so if I want to loop through the elements, I can't make references to t. I have to have them be constant references to t. Or actually, I'd rather do it t const reference. And we can see that works, although it's complaining about the return statements and the other functions still, which isn't a big deal. So just to be clear, the error I had a minute ago is now gone. And the error was I was taking as an argument a constant vector or a constant list. That means all the elements are constant, so I should say not just t, I should say constant t as my element type. If I try running that, we see the number of times that, okay, what are my test cases? I count the number of occurrences of apple in my list of strings. Okay, so that would be 1, okay, there's 1 of them. I count the number of times B occurs in my set of characters. That's fine. I think we do owe it one more test case here. Let's have apple occur twice in the list of strings. Okay, so apple occurs twice. Fair enough. I'm going to claim this is now correct because we've written this before. What I will observe, though, is before I compiled the first time, I said, let's try this, but I'm going to come back to it. I would probably just write this, auto ampersand. I wouldn't bother with a T. Once the auto keyword came into existence, a lot of uses of templates became way easier, if not sort of redundant. We didn't need to care that much about templated types as much. And interesting to note here is that error I had involving const doesn't happen if I use the auto keyword, because the auto keyword subsumes any constraints on the elements of the container. If the container only contains const ints and t happens to be int, then I could just write auto, and auto will figure out that the element type is const int and then allow me to use it. So I wouldn't need to worry about that. One more good reason to use the auto keyword. So that's count occurrences. Now let's do this one. Okay, this one's weird. So the function is called concatenate strings. And the problem is that it's taking a type t, but isn't t always going to be string? I mean, if the point of the function is to concatenate strings and it says it takes 2 strings, then aren't these always just going to be strings? I'm going to ask ChatGPT to explain itself. I'm going to ask a constructive question. Can you give an example of a case where the arguments to the concatenate strings function would not be of type std string? So in other words, why am I using templates for this? Certainly, here's an example of a case where the arguments to concatenate strings would not be of type std string. Okay, it wants me to specialize for C-style strings. And we already know about C-style strings. We learned about those in 111. And you know what? Executive decision, we don't want to learn about them again in 116. We like std string. I fastidiously avoid the use of C-style strings in C++. I have an absolute dedication to avoiding them. Assuming that I never use C-style strings, is there a case where concatenate strings would take arguments of types other than std string? Now, the answer is, I mean, basically always yes, because you can make up your own type that mimics a string, but I'm really trying to figure out what it wants me to learn from this exercise. Like, what is the intended learning outcome? If you have an absolute dedication to avoiding C-style strings, then in your specific coding style, it's unlikely you'd pass arguments of types other than std string to the concatenate strings function. The concatenate strings function, as originally defined, is designed to work with strings like std string. It could accept other arguments that are of the same type that could be implicitly converted to std string, but otherwise it wouldn't. That's fair enough. Now, as far as the C-style strings business, the issue with C-style strings is that if I use C-style strings, I could try and concatenate them with this function, but I need to use what's called a template specialization, which it's actually done here, because I can't treat them the same way I would treat std string because they behave differently. And that's one more reason to not work with them. If you want a C-style string in C++, you can use std string. There is a function on std string that will give you a C-style string version of that string. That probably is the safest way to work with C-style strings if you need them. So I'm going to implement the concatenate strings function with the assumption that the caller will not use C-style strings because they wouldn't do that in CSC 116. Now, I guess I could make one concession here. So I'm going to assume that my return type is std string. So I'm going to call that result. And I'm going to return that. Oh, actually, no, and that does tie my hands. So if the return type has to be type T, and I'm saying that the result has type string, I'm assuming that T has type string. I've got no way around it. What I was considering is if you make a type that is similar to std string, then you could write a concatenate function that works even on that type. So even if the type you create doesn't have a plus operator, because the obvious answer to this, if it's always going to be std string, is just to return str1 plus str2. Like that's literally all we have to do. Even ChatGPT concedes that. It actually does that in its model implementation. It does str1 plus str2. In the interest of reading a bit too far into the exercise, you could also try this. Suppose you write a string type that doesn't support the plus operator the way that strings do. I guess you could try something like this. You could say, okay, for each character in each string, the result dot push back. I don't know. You add the character to the result and then same story for the other one. So there is a way to try and, I don't know, make the exercise a little bit more exotic. I don't think this reduces the assumptions I have to make because why would it have push back, right? I mean, ultimately, whatever I'm creating, I have to make certain assumptions about what it supports. So who knows? So just for the sake of variety, we'll try this version. And then I return the result. Okay, we'll see what this does. So I think that was a bad exercise. I don't think that went anywhere. But it does look like it works. So I implemented it, although it was a bad exercise because it was sort of trivial. So I concatenate hello and world, and I get hello world. We'll just call that exercise done and move on. The next one is calculate average. Okay, so calculate average, just like with the first one, I'm going to ask it for a formal specification. Can you write a header comment containing a formal specification for the calculate average function? Don't show me the solution. Okay, here it is. Great. We'll just grab it and we'll take it back over to our code template. We'll just paste it right in there. Calculate the average of elements in a container. It takes a container of numeric values and calculates the average. If the container is empty, this function returns 0. Oh, but it says numeric values. All right, that's weird, but okay. I'm actually going to write return 0 as my handling for this. This is a bit flaky. I wouldn't do it this way. Just like with the first example, I would probably throw an exception, but it says to do it, so I'll do it. So if container.size equals 0, is there a way around having to assume that there's a .size function? Oh, I think there is actually. Let's assume it's a container that I can iterate over. In that case, what I could do is I could say, I'm wondering whether I need to use a little bit of, Yeah, I need to do at least, I need to do something here to figure out what the type of the elements of the container is. So what I want to do is make up, oh, it says double. Oh, well, there we go, never mind. So it's made a constrained version of the function. I was afraid this was like type T, and it isn't. It's type double. So if it's going to return double, then I can assume that the elements can all be converted to doubles. So I'm going to make a sum variable that has type double. I was worried about what if it wants me to compute the sum, and then maybe it's of some random integer type or something. How do I figure out what the type of elements is? I would need to do container : value type, or I would need to use an iterator in a certain clever way. But here I don't, because the result's a double, so I'm just going to use a double. So I'll say, and what I'm going to do to figure out how many elements are in the container, I'm just going to count them as I walk through it, which means I don't have to make an assumption about how to find the size of the container. So for auto element in container, it wouldn't be appropriate for me to assume that the elements are all doubles. It could be a vector of ints. I just want a double result. So for every element in the container, sum plus equals element, and then count plus plus. And then when I'm done, I return sum divided by count, unless if the count is equal to 0, well, then I've got a problem. Then I just return the double value 0. And this whole return 0 business, although I still don't agree with it because I think the average of an empty container should throw an exception, here it makes sense. I just return the double value 0. There are no typing shenanigans because the return type is always double. Although, again, I disagree with that design, but I didn't get to make the design. All right, what's the problem here? Result, oh, whoops, result, okay, return. Looks like that worked. Let's try running it. And it says, let's look at our two vectors. Int vec is 1 plus 3 plus 2 is 6, plus 5 is 11, plus 4 is 15. If I average that, that's dividing 15 by 5. That would be 3. Yep, that looks good. The average of the vector of doubles is 3.3. That also checks out. Okay, so that looks good. And then I've got one more function. It is key exists. Okay, let's go stare at this and see if we can make sense of the two-line explanation. So here there are two templated types. So that would be key and value. And it takes as argument a map, which maps keys to values of type mymap, and then a particular key called key. And I have to decide if that element exists. And you know, this would have been a lot more challenging before C++20, but I think ChatGPT has forgotten that maps have this contains function now. Mymap.contains key. Is that really enough? Am I missing something here? It compiles. Huh. Okay, well, there we go. So the key exists returns a Boolean value. When you try and print a bool, it prints as an int. So it prints as 0 or 1. And so, okay, key exists. If I have, so my map contains these keys: the word 1, the integer 1, the word 2, the integer 2, the word 3, the integer 3. So it then asks, is the word 1 in my map? And the answer is yes. Is the word 4 in my map? The answer is no. Because my implementation was one line long, I'm going to say I think we've tested it sufficiently. I'll observe this interesting thing. When ChatGPT wants to call key exists, it actually has to pass in std string, which is the element type of the map. I think it's because it's worried that if I just type a string, the compiler will get confused. So it's actually constructing explicitly a temporary string object, as opposed to just passing in a string and hoping the compiler figures it out. And it's right, actually. It says don't do it. It says the compiler will say, I won't do this. Because if you pass in this argument, the compiler reads anything in double quotes as a C-style string. In other words, a value of type const char star. And this confuses the templating. So to get around that, ChatGPT has said, no, I want an std string object. Construct me an std string object by calling the constructor manually. I would do this with curly brackets, but it has the right idea. And you can see it's calling the string constructor to construct a temporary string object to force the compiler to understand that what I'm passing in is supposed to have type string, not type const char star. So interesting that it caught that. If I were writing this testing code myself, I wouldn't have done that. I would have seen the error and had to react. But ChatGPT somehow figured that out. So for all of its other faults, it figured that out. Okay, I think that's enough. I think that's enough exercises for this video. I don't know what other template exercises I can expect it to give us for this week. I'm going to ask it for one more, and if I like it, I'll do it. If I don't, I won't. Those exercises were nice. Can you generate, let's ask it for 2 more exercises in the same format but with new starter code, because I don't want it to add it to the, and we'll just see what it comes up with. Okay, find the first occurrence of something in a container. That looks interesting. And then remove duplicates. Those both look sort of neat. You know, yeah, I think I want to do both of them. Those are both great. Actually, great. They're both great. Okay, so that's just typing on autopilot. There is an issue that I have, though, which is that none of these exercises have given us practice in writing the signatures, and I'm sort of sad about that. I don't know how much practice we need for that, though. It does feel sort of like the signatures in all those cases have been relatively easy to deduce. So I guess we'll leave it. Yeah, we'll say these are both great. Great. Can you combine both exercises into a single piece of starter code and add a main function where you have written test cases for each function? We'll let it think. Certainly. Okay, here we go. It has, in this case, even written nice specification comments, so avoiding that irritating two-line thing that it was doing. So I'll go write this. I wish that it would generate exercises that require me to templatize something. I'm not sure what, I guess I could have written a prompt that does that, but I didn't. I ran out of time, I didn't. Because I think it is useful to have practice with that. So, okay, one thing you ought to do is ask ChatGPT to give you some code that needs to be templatized, and then you can figure out how to templatize it, and then see if we can do that. Okay, now in the meantime, here are our new test cases. We've got we make a vector of ints, and it says find the first occurrence, and it looks for the element 3, and it looks like what find first occurrence is supposed to do is return the index of the first occurrence of something. We do that also with a vector of strings. That's a good idea. I actually do it with both vectors and lists. That's interesting. I'm just going to get my compile commands sorted out here. And then the other function is remove duplicates. Okay, this is making a huge mess. That's weird. What? Oh, it didn't paste the whole template. Okay, well, that's not... I was wondering if ChatGPT had made a mistake. It's pretty good at writing syntactically correct code, though. Okay, I'm going to paste this in. Did it all paste in this time? Okay, we'll try it again. Okay, so it looked like it did compile, which is good, although it gave a bunch of warnings, or just this one warning, which doesn't surprise me. So there are two functions. I already talked about find first occurrence. Remove duplicates. Okay, so... I see. Okay, so it looks like remove duplicates takes a vector or a list and then produces a new, or when the function is over, the vector or list has had all the duplicates excised somehow. I'm going to implement this the way that I normally do such a thing, which is by creating a copy. It doesn't say that I have to do the operation in place. It sort of implies it, but it doesn't imply it strongly enough. I'm not going to take the hint. I'm going to do find first occurrence first, though. So find first occurrence is interesting because it allows me to work with lists. So although what I'm returning is an index, it doesn't expect that the structure that I take as an argument actually allows indexing. So lists don't have a .at function. So the way I'm going to do this is I'm just going to step through my list or vector with a for each loop and count off positions until I find the thing I'm looking for. So I'll try, I'm going to say, let's see, int idx starts at 0, and then I'm just going to loop over all the elements. So for auto element in the container, I'll save myself some trouble here by using auto ampersand, because maybe the elements are large. I don't want to make copies of them. If the container is constant, as it was earlier, the auto keywords subsumes that. So that means that even if this is a const container, which it is, the constant elements, the auto type will integrate that constant property into the type of the element. So I'm just going to ask, oh, whoops, okay, auto x. The value to search for is called element here, not the name I would choose. So if x is equal to element, now it doesn't say this, but I am going to make this assumption because I have no other choice. It doesn't say that I'm allowed to assume that the element type has a double equals operator, but if it didn't, I don't think I'd be able to implement this at all. So I'm going to make that assumption. I think that's a solid assumption to make. So if x equals element, then I return the current index. And if otherwise, I just move the index along and keep going. And if I get all the way to the end of the loop and I still haven't found what I'm looking for, well, in that case, I guess I return -1. And that's specified specifically as things ought to be specified, as the case, how to handle that situation where the element isn't found. There's find first occurrence. We'll try running this. And then there we go. So it says if I look at my int vector is 1, 3, 2, 5, 4, 3, 6. Find first occurrence. The first occurrence is at index 1, and it returns 1. It looks for the element 7, which isn't in there at all, and so that's going to be -1, which it does return. If I look for banana in my list of strings, that's a nice list of strings. That's the kind of list I would write. Then we get index 1 again. If I look for grape, which is not in there, then I get -1, which is expected. I'm going to do one more test, which is, we've noticed it's good at returning -1s and +1s. I want it to return at least one other positive number. Okay, so it looks like it works. I'm going to call find first occurrence as finished, as implemented. So what about remove duplicates? Okay, so it takes a container, which it says is going to be vector or list. And this is a tough one, because if we want to write this to work on any container, it's not going to be easy, because we have to make certain assumptions about what containers support. I think if we wrote this to work on sets, it wouldn't require too much of a change, although I guess sets wouldn't contain duplicates anyway, so we don't care. I'm going to act on the assumption that we're always working with vector and list in this case. So here's how I'm going to do that. You've given me the type of the container, so I'm just going to make a new container. And then I'm going to loop over the old container. So for auto element, auto ampersand in container. And I'm going to go searching to see if it's already been added to the new container. So bool already added starts at false. Now for auto new element in the new container, I'm going to say if element equals new element. Like before, I have to assume that a double equals operator exists on the element type, because if not, what am I supposed to do? How do I compare elements? If element equals new element, then I've already added this. So if I go looking for it in my new container and it's already there, then clearly I've already added it, so I don't want to add it a second time. If I get down to the end of this search and already added is equal to false, so I like writing if statements that look like this for that purpose. If I haven't already added the element, then I add it to my new container. New container.pushback element. So pushback does exist on both vectors and lists. So when I'm done, I get to the end and I just say, now take my old container and delete everything in it. So just overwrite it with what's in my new container. So basically make a new container with the desired properties and then dump it into my old container. And let's see. So if I remove the duplicates in int vec with duplicates, 1, 2, 2, 3, 4, 4, 5, I do get something with no duplicates. Same thing with the one with characters. So this is a list of type char, which is sort of unusual. And in the one with characters, it becomes clear that even if elements are duplicates that appear far apart, they do get removed. But I am still going to do that. I'm going to add a case of that to this one just to make absolutely sure. This test case by itself is a little bit suspicious, because here there are duplicates, but they're all next to each other, which means maybe my code isn't working correctly. Like maybe it doesn't handle the case where the duplicates are far apart. So I do want to test that. It does look like it works. I'm going to call that as complete as well. And now I'm pining to try one more exercise where I have to templatize it. Maybe I can't do that. Maybe ChatGPT doesn't know what I mean, but I'm going to ask. Those exercises were great too. I want one more exercise, but it's a bit different than the others. Can you give me some C++ code, C++20 code, containing functions and a complete main function that containing, I'm going to say, non-templated functions, and a complete main function that tests those other functions, but where the functions have some redundancy that could be eliminated through the use of templates. The exercise is for me to find out how to templatize the code. Don't show me the solution. ChatGPT is pretty good at reading English, so even really convoluted explanations like that, assuming it made some amount of sense, I might be able to get what I want. Yep, it looks like it figured it out. So here I've got findMax in vector, and it seems it's a complicated and not necessarily the way I would write it, but it seems to be a function for finding the maximum element in a vector. And then the same for a list, and then there's main. Okay, this is what I wanted. Let's try this out. So I'm going to copy this code. I was hoping for more than one function, but it gave me one function, so we'll try it out. So it's two functions: find the maximum in a vector, find the maximum in a list. Now, some of this is going to be contrived because we've sort of done findMax, the general version, already, but let's just try it out and see if we can get something out of the exercise. I mean, beauty is in the eye of the beholder or whatever, so practice templates 3. So I've got this vector in this list, and the vector contains 5 in the middle, and 5's the maximum. The list contains 10 at the end, 10's the maximum. Both functions work correctly. My impression is I have to turn this into just findMax, a single templated function. I've got to find a way of turning these two functions into one implementation that does something that is substantially the same. So I look at this and I observe, if I turn this implementation into findMax, it's not going to work on lists because it tries to index, and lists don't have indexing. If I look at the list version, it uses .front, which, as far as I can recall, does exist for vectors, unless I'm mistaken. Let's see what happens. Can I compile this with dot? Oh, actually, okay. I'm going to go back to my original template. Before I modify anything else, I'm going to try modifying the vector and list versions to make them as similar as possible to each other. So I'm going to say vec.front. Does that work? Can I use .front on a vector? Yes. Okay, so by doing this, I can make the vector and list versions pretty much identical up to the types involved. And now all I have to do is use templates to get rid of all those types and turn them into placeholders. So I'm going to call the findMax function. And I'm going to pass in this first case, a vector of int. In the second case, a list of int. And actually, to make it more interesting, I'm going to turn this into a list of double. I'm going to change this to 8.9. And then we'll change this to double. And I think that's all I have to change in main. So I'll call this, it should be called double list, I guess. And now I want to write a single function called findMax that subsumes both of these use cases. So I'm going to use the list version as the basis. I'm going to say findMax, and it's going to take as its argument, So in this case, I've got to try, this is going to require some cleverness. So template type name t, and I could try taking t as my argument. So you give me a thing, so maybe I'll call this container like before, container. Type name container, I'll call it container, I should say container type. Type name container type. And that could be a list or a vector. Container type, we'll call it, we'll just keep it at LST, I guess. If the container is empty, then I return, I'll just say container is empty. Otherwise, I go get the first thing, and .front does exist even if LST is a list or if it's a vector. Now there's this issue, though. So what do I use for the type of the maximum value? If I use an int, it's not going to work if I pass in a container whose elements are double, and vice versa. I could cheat and say, well, let's assume it's always a double, because I can treat an int as a double in certain cases. That's not great. What else? I could also use auto, actually. And I could even use auto, although this isn't a good idea on an exam because you're told specifically to use explicit types. I could even use auto as the return type. I think that would work. Oh, no, it doesn't. Right, so it says, oh, that's a tough one. So this error value of -1 actually gets in the way a lot, because what's happening here, this is an unusual error, but basically what's happening is, if I didn't have this case here, if I didn't have the if the list is empty case, I think this would work. Yes, and the reason it would work is because the return type of the function, the auto here, for the compiler to let you use a return type of auto, it has to be able to figure out from the context of the function what you're trying to return. The way it does that is it looks at each return statement and says, because at any point in the code, the compiler does know the type of every variable and expression, if you look at the return statement on line 23, you can work backwards to figure out the type of the variable maxval. The type of maxval is the element type of the list, which is the element type of the container that you gave me to begin with. And if you work backwards, it becomes clear that if you gave me a list of double, then maxval is a double, so I'm returning a double, so auto is a double. If you gave me a vector of int, similarly, we figure out the return type should be int. That's fine. When I bring this back, we have a problem. And the problem is that this -1 is an int. Because when I write a -1 with no other adornments, like I don't write 1.0, when I write -1, that is interpreted as an int. So in this version of the code, suppose you pass me a list of double. So you can see here the complaint the compiler gave, which is pretty cryptic. The complaint the compiler gave involves list of double. So it's clear this is the case that's giving it indigestion. It didn't seem to have a problem with this one, with passing in a vector of int, just list of double. The problem it has is there are two return statements. One of them returns an int, and one of them returns a double, and it doesn't know what to do. It says inconsistent deduction for auto return type. You give me int, and then you give me double. I don't know which one to use. So how do I work around this? Well, normally if I need to use an element, I could just say, give me an element out of the list. But I can't do that because obviously the list has no elements. I can't return an element that doesn't exist. So how do I work around it? Let's try, there is something I can do, which is to avoid the use of the auto keyword. If I can figure out the element type of the list, I could return that. And there is a way of doing that with vector and with list. So with list and vector, if you want to know the type stored inside the list or the vector, it's automatically given to you like this. So if I say std vector of int, inside the vector type, there's always going to be this thing called value type, which tells you the type that the element type of the vector. So for a vector of int, value type always is int. And for a vector of double, value type is always double. And then the same thing is true with a list. So list of double : value type will be double. This is a convenient way of extracting the value type out of an opaque template argument. So I could write container type : value type, except if I write it this way, the compiler is going to get confused. I have to tell it that what I mean here is that this is meant to be the name of a type. So I have to say type name, I think. This is one of those things, you'd never get this on an exam because where to put the word type name is something that's even a bit of a hassle in a fourth year course. It's not something that's easy to always remember for everybody. So, and even I don't remember every case where I need the word type name. That works. I mean, that does the trick because here it says the return type is going to be this thing. Container type : value type. If you gave me a list of int, then this is going to be int, which means when I return -1, I'm returning an int. If you gave me a vector of double, then this type is going to be double. So if you try return the int -1, then it turns it into a double because it knows you're supposed to be returning a double. So this works, but it's clunky, and it required me to know this fact from elsewhere, this fact that I might not already have known. And I don't think that, I think there should be a solution that doesn't require that. Let's see if I can find a way of using auto for this. Okay, how about this? I can't access any elements of the list you gave me because that list was empty, but I do know the type of the list. So let's try this. This is really weird. This is not a good idea. What I just did involving type name is a good idea. Like it's esoteric or it requires extra knowledge, but that's the correct way of handling this. What I'm doing now is sloppy, and it's mostly just a way of trying to find a loophole. On an exam, not that you'd be given this question on an exam, if you find a loophole and the code is syntactically correct and doesn't have logic errors and doesn't dereference null pointers or whatever, if the code always works correctly, then you'll get the marks, even if your solution is sort of janky, for lack of a better word. Here's what I'm going to do. I'm going to make up a new list, container type, I don't know, bogus list. And then I'm going to add -1 to it. And then I'm going to return that element. So I'm going to return bogus list.front. Because there's going to be one element in my bogus list. And it's going to be the whatever -1 translates into in the element type of my list. Let's see if that works. All right, there I was able now to exploit the loophole. There it is. This is a stupid solution. Don't actually write code that looks like this. Okay, so there's one way around having around that weird error it gave with the type inference. There's one other thing I'll point out, which is that, what would really work well here is having a better error handling policy. What I should do if the container is empty, instead of printing a message and returning -1, because -1 could be the maximum element of the list, what I should do is something sensible like throwing an exception. Throw invalid argument, error, empty container. That is a sensible, that's why we have exceptions in C++, is to handle weird cases that couldn't be handled by normal logic. That's what I should be doing here. And if I do it that way, then I can use the auto keyword as the return type. And that works. Okay, so this is a much less sloppy solution than what I just had, although it required me to modify the specification. But, this was a bad specification. So if nothing else, I deserve the right at least to mope or to complain about the specification. Okay, that's enough template exercises for now. I think we covered all the possibilities. I think that's the best ChatGPT could do. We tried asking for other forms, and it didn't seem like it had that many ideas. And it gave even this findMax exercise that was a variant of something it already had. So whatever. We'll see whether it can give us more uses of templates next week when we ask about data structures.